Okay, question 1a for your test. Okay, sketch the graph of two functions gx equal to cos x and hx equal to x over 2 on the same plane. Choose a, b that satisfy magnitude b minus a is 1 unit. Then approximate a solution to the equation with gx equal to hx in the chosen AB by using intermediate value theorem. X marks here. I think you're sketching the graph. Okay, this is a cos. Yeah. Okay, this one is actually a cos pi over 2, 1.7 something. Okay, cos pi over 2 you have 0. Cos 0 is 1. So you want to get perfect, okay, 4 marks, you must have the shape of the cos x. The intercept must be correctly. Cos 0, you know that cos 0 is 1. Cos pi over 2 equal to 0. So you want to see these two intercepts there. Okay, and then y equal to x over 2. So you're labeling, okay, the linear graph, okay, 1 and the correct the correct intercept, correct, okay, here means some y equal to x over 2 passing through, okay, x0 y0 here. So when x is 1, y is half. Mean this value should be reasonable, okay, half here. So you can see that the graph of y equal to cos x and y equal to x over 2, they intercept roughly, I think, here. So the root is actually the intercept of these two curves. So it's between, you will not see clearly, is 1 to 2. You may put, I think, if you put 0 to 2, you deduct you, okay, some mark because we want the magnitude is 1 unit. So you can see it's actually greater than 1. So it's 1 to 2. That's why you choose A to B, which is 1 to 2. Okay, the graph here, okay, with the correct labeling, you have 4 marks here. And then here 1 2 1. Okay, from the two function given, make it become one non-linear equation. It's either you want cos x minus x over 2 or x over 2 minus cos x. Here 1 2. And then, okay, using intermediate value theorem, so this is your fx. Then you just find f1. F1 you have the positive 0.0403. F2 negative 1.4161. Okay, and then according to intermediate value theorem, okay, F1, okay, F1 positive, F2 negative. When you multiply positive multiply negative, the result is negative, so less than 0. Okay, and then I don't know why some of you negative the result positive, you still can say this is negative. Less than 0 mean negative. How to get negative? One, okay, FA, one of it must be positive, one must be negative. Then the product will be negative lah. So easily you have here 2, means here 1, 2. So 8 marks there. Okay, question 1A. Okay, can you access to the Google Drive? I put,
Can, Doctor?
Yes, Doctor, can.
so the 1A 8 marks, 1B 6 marks. So a system which is represented by the given equation below able to work effectively even when the time is 0. So the function ft here. However, there will be a time where the system is put on resting mode for several seconds. By using Newton-Raphson method, find the approximate resting time between the interval 1 to 2. Okay, with system function tolerant less than 0.005, do the calculation in 4 decimal place. When time is 0, so mean you want to find what is the time when ft equal to 0. So this is a Newton eruptions formula. And then here's 6 mark. I will give for your derivative 21 t squared 0.62 t plus 8 plus sin t. This one I will give 1 mark. Mean you differentiate ft, so ddt 7t cubed 21t squared. Okay, ddt negative 0.31 t squared, so you have 2 times negative 0.31, which is 0.62 t. ddt 8t, you have 8 ddt negative cos t. Okay, differentiate cos negative, negative positive sin t. This one 1 marks. Okay, and make sure you choose the interval they want in between 1 to 2. If you choose 0, I think I will deduct maybe half or 0 mark there, because they want you to use the initial condition from 1 to 2. So you may choose 1 or choose 2 or 1.5, something like that. So this is a ft, this is a f prime t. And then at step number 4, you see the f number 4 is less than epsilon. Then you can stop. Want to stop. The the t is approximately 0.1230. So 6 mark 1. I don't know. Conclusion, I give 1 marks. So total 6 mark. This one make sure is correct. Those I think there's a group of student. The ft value 13 point something. Then this one totally wrong. There is a group of the student with the same answer. So I don't know how you calculate the ft, will get you wrong. How can you get 13 point something? So this is question 1b. I wonder how you can get 13 point something out there. If you use calculator, number 1, 7, let's say t, we put x minus 0.31 x squared plus 8 alpha x minus cos alpha x. 7x cubed minus 0.31 x squared plus 8x minus cos x. Make sure in radian. Because you got trigonometric function, make sure in radian. Maybe you're not in radian. So calculate. Then why cannot calculate? Oh, matrix 1. Radian. So 7x cubed minus 0.31 alpha x squared plus 8 alpha x minus cos alpha x. Calculate. X is 1. 14.1497. Unless the first person that make the mistake and the rest of you copy get the same mistake. No wonder. 13.9602. In the beginning of the class, I already advised you that you can always set it in radian. Angle unit, I always advise you to set up in radian. Always set it in radian. Because like this one, if you have a trigo, you forgot to change in radian, then the result wrong. So everything gone. So at most I think I give you 3 marks only. So this is the Newton eruption method for non-linear equation. Okay, and question 2. Okay, solve the system of linear equation below by using Gauss elimination method. Unfortunately, your question paper coordinator, I think, accidentally deleted the statement where A, B, and C are last 3 digits of your metric number. For example, AFC 200 ABC. If the digit of your number is 0, then take 10. Okay, and there is a group of students. Okay, I wonder how you can guess with the marking scheme which provide 198 exactly. And then those you cannot some who replace the ABC with 111 or any value, you can get it correctly. Some, if you perform using ABC, I think none of you get it correctly. And then when you find something weird in the test or final, please voice up, because we didn't notice that this statement has been deleted. And then I just wonder why a group of students, you can guess exactly in the marking scheme. Okay, here 198. Then you perform the Gauss elimination exactly. Okay, here is I think 8 marks. Easily you can get it. Okay, and for those who perform using this one, using the ABC, and you see the A2 Gauss eliminations, so you no need to swap anything. Okay, so if you still carry the ABC, then the answer later on will in terms of ABC. Okay, A21 already 0. So no need to eliminate it anymore because it's already 0. Okay, the purpose of Gauss elimination method is actually we would like to reduce until the metric A become upper triangular metric. This is already 0. So no need to reduce. Then you just need to reduce 7 here. Okay, if you perform using A, then the operation, when we want to target to make A31 become 0, okay, the operation is negative A31 divide A11 multiply row 1 plus row 3 put into the new row 3. Okay, so it's negative 7 over A row 1 plus row 3 put up into row 3. So in column 1, the row 1 is A plus 7. So that's why you get 0. Okay, that's why you have A 2 0. This is 5. Okay, second row, no need to do anything because A21 already 0. This is why. This one you get 0. Then when you move to column 2, negative 7 divide A. When you move to column 2, row 1 is 2. Row 3 is 0. Row 3 is 0. Yeah, how to erase? Okay, column 2, row 1 is 2, row 3 is 0. So you plus 0. So the answer is negative 14 over A. So this is negative 14 over A. If you perform, use carry on the ABC. A22, you get the result negative 14 over A. Column C, the third column, third column. So negative 7 over A. Third column, row 1 is 0. Then you plus row 3, which is C. Okay, 7 times 0, you have 0. So plus C, this is C. Column 4, negative 7 over A. Column 4, row 1 is 5. This is A. Okay, row 3 is 3. So you have negative 35 over A plus 3. So this is negative 35 over A plus 3. Okay, if you perform, use carry on the ABC. Okay, this is step 1. this entry negative 14 over A, and then this is C negative 35 over A plus 3. Okay, let me here. Okay, this is using ABC. So the ABC, this is given by coordinator, the row operation 1 marks, and then up to here 2.5. Then later on you see the purpose of Gauss elimination. If we want to reduce until upper triangular matrix, so we need to eliminate the A32 in the R3 prime here become 0. You want to eliminate this one become 0. Okay, the operation is actually negative A32 prime divide A22 prime, mean from the latest system. Okay, multiply row 2 plus row 3. Okay, so that's why A32 is negative 14 over A divide A2, okay, A22. So you get negative, okay, negative, and then A32 you have negative 14 over A, okay, divide A22 prime, which is B, multiply row 2 plus row 3. Yeah. So that's why negative negative become positive. So 14 over AB row 2 plus row 3 prime. Okay. So mean using the latest system. And then when you focus on column 2, column 2, your row 2 is B. So that's why you have 14 mean AB multiply B plus row 3, which is negative row 2 plus row 3 minus 14 over A. Okay, mean here the row operation is 14 over AB multiply row 2 plus row 3 prime. Okay, in column 2, row 2 is B. So B and B cancel. So 14 over A minus 14 over A, that's why you get A32 0. And then you need to perform to column 3, column 4. So for column 3, you have 14 AB, okay, multiply row 2, which is 6. And then plus row 3, which is C. That's why, 14 times 6, you have, 84 AB plus C. That's why if you, ask, then you won't perform so tedious, operation because ABC there. If you, or you put out any value, then will be easier. So that's why this one is the third column, 84 divide AB plus C. Okay, for column 4, you have 14 AB, okay, multiply row 2, which is 4, plus row 3, which is negative 35 A plus 3. That's why, 14 times 4, which is 56 over AB, minus 35 over A plus 3 here. So again, 1, 2, 2 marks. And then, so now, after one step, two step, we reduce it to upper triangular matrix and you use backward substitution technique. You can perform, can find your, the XYZ value from the last row. 84 AB plus C Z equal to 56 over AB minus 35 over A plus 3. Hence, Z, you take 56 over AB minus 35 over A plus 3 divided by 84 over AB plus C. Here. Just leave it here. And then from the second row, by plus 6z equal to 4. Hence, y is equal to 4 minus b. Okay, we want to calculate y. Yeah? So 4 minus 6z over b. Okay, z no need to replace because z we know is here. Okay, from the first row, ax plus 2y equal to 5. Then x is 5 minus 2y divided by a. Okay, we know y you can plug in here. So this is question 2a. 8 marks there. And then okay, question 2b. So this is a 4x4 system. Okay, then use the Gauss-Seidel iterative technique to find approximate solution to x1, x2, x3. Start with 0, 0, 0 transpose. Also, suppose no comma there, because this is a also column vector until maximum xk plus 1 minus xk less than epsilon equal to 0.005. Here actually I already provide you the template. I wonder why you don't want to use it. If you plug in the template, that's why I don't understand. I already provide you the template. The Gauss-Seidel. You just plug in here, plug in your A, your B. This will be automatically out, but you don't want to use it. Then you want to perform manually. Then Gauss-Seidel, make sure you the metric A is diagonally dominant. Or you change it, this one, 10, -1, 2, 0, 6. So first row, 10 is greater than magnitude of this is 1 plus 2, 10 greater than 3, so it's safe. Metric A is correct. Second row, -1, 11, -1, 3. Magnitude of 11, you have 11 greater than summation of magnitude -1 plus magnitude -1 plus magnitude 3, because 11 greater than 5. Second row correct. Third row, you have 2, -1, 10, -1, -11. So again, this one also dominant, 10 greater than 2 plus 1 plus 1. The third one, the fourth equation 3, don't have x1, so this is 0. 0, 3, -1, 8, 15. So again, 8 is dominant compared to, you add up here 3 plus 1, 4. So this is diagonally dominant. Diagonally dominant. And then one is diagonally dominant. Then you can put out the formula for your x1. Make sure you you want to solve for x1, x2, x3, x4. x1, focus on x1. So the other two equation you bring to the other side. X1, make sure is step k plus 1. Write down properly the max equation. 6 plus, initially we can put 6 plus x2 minus 2x3 from equation 1 makes the x1 as a title. So divide by 10. You cannot put x1 here. Mean with the initial eigenvector, not is eigenvector, initial x. This is a x. The x actually you have 0, 0, 0, 0. This is x consists of the x1, x2, x3, x number 4. This one at step 0. Everything step 0, step 0. So that's why initially you have to put when k equal to 0 with x2 0, x3 0, you can get x number 1 at step 1. To write it mathematically, your the superscript k plus 1 at the left side and the right side, make sure you write it properly. That's why you can obtain up to here. Those who do it manually and you didn't write down properly, I will deduct some of the marks there. Here. And then I still saw some of you still cannot write down this equation. To write the equation, it's very simple. Let's say to write the second equation, focus on x2. The other two variable bring to the other side. That's why x2 initially put like this, 25 plus x1 plus x3 minus 3x4 divided 11. And then left side you put k plus 1. Okay, right hand side x1 you have the k plus 1 value, mean the new value, latest value. So x1 must be k plus 1. X3 still O, that's why okay, level k. X4 still O, that's why level k. So later on go to x3. So x3 negative 11 minus 2 x1, we focus on 10x3. The other variable bring to the other side. So negative 11 minus 2x1 plus x2 plus x4 divided by 10. Left side put k plus 1. Right hand side x1 you got new value, so k plus 1. x2 got new value, k plus 1. x4 still O, that's why k. And then go to the last equation, solve for x4. So you have 15, this minus, this become plus, and then divide by 8. 15 minus 3x2 plus x3 divide by 8. Okay, x4 k plus 1 mean the new x4. x2 you have a new one, so k plus 1. x3 got new one, so k plus 1. That's why you got this thing. So 2 marks. Okay, those who use the template, I didn't deduct because okay, in the template, okay, when I asked you to use the template, I forgot to tell you that. But if you don't write down conclusion, I okay, deduct 1 marks there, because I always mentioned you must write down your stopping criteria and the last answer there. It's suppose okay, if you use a template, it will automatically out, okay, but we want you to okay, show also the manually okay, the formula, but I didn't deduct because I forgot to tell you. Yeah. Okay, and then those who stop at 5 will deduct you maybe half or 1 mark. I forgot already, because if you stop at step number 5, you see, if you take this one deduct, okay, this value when you deduct it 0.008, mean those who okay, use x5 deduct x number 4. If you x5 deduct x number 4, okay, you have 4 value. One value is 0.0008 greater epsilon. That's why you cannot stop at number 5. Because this one minus this one, take the magnitude, okay, 0.008 greater than, this one is greater than epsilon. So you cannot stop. That's why you need to perform one more step. Okay, when you perform one more step now, okay, you perform one more step. So you see, you have okay, should have 4 value. Okay, 1 minus 1.001, the magnitude is 0.001. This one 0, 0, 0. So the maximum is actually 0.001 less than epsilon equal to 0.005. So the solution is x at number 6, which is 1, 2, negative 1, 1. Okay, then should be the column vector. We put it horizontal, that's why transpose. So this is a Gauss shader. And then question 3. So I always said answer according to the question. Don't answer whatever you understand. No use. Because we just mark based on the question, based on the marking scheme only. We just want first order. Easily you can get 7 marks there. And then make sure we say interpolations. Question 3a. Where is it? Yeah. You want to estimate the velocity when t equal to 16. 16 in between 15 and 20. So okay, linear just need 2 data. So make sure you extract the correct data. You put 10 and 15, then wrong. Because 16 outside of the range. I always say interpolation. Inter mean inside. The value that you are going to estimate, make sure inside the list. So you must take out 15 and 20. And then okay, linear, I think you can perform it manually easily. This is okay, the result here. Easily you can get, I think, 7 marks. In linear approximation, so you want to estimate velocity vt. So okay, the L nodes is a t minus t1 divide t naught minus t1 multiply v, okay, t nodes, okay, plus this is a L1 t minus t naught divide t1 minus t naught. So plug in all the t naught, t1, okay, v naught, v1 value, you can get it. Okay, this one you okay, is simple calculation. You may just do manually. Okay, you get this result. Okay, and lastly, the question 3b, use Newton divided difference method, find 3.5. And then I don't know why you all can everything wrong. If you start from level 1 you're wrong, then everything will be wrong. Okay, so this one, this cell is actually, yeah, can I have other color? F 1, I mean the first value F01. Okay, actually it's actually like you calculate the gradient. I mean 33 minus 1245 divided by -1 divided by 4. I mean the formula is, okay, you want to get this value, takes a previous column, next row, deduct the previous column, same row. I mean this is F1 level 0 minus F0 level 0 divide by, okay, 0 plus 1, this is x1 minus x naught, which is 33 minus 1245 divide -1 minus -4. In here, where you can perform a minus b divide c minus d. Calculate. This is a, this is b, this is c, this is d. Okay, a is 33, b is 1245, c is -1, d is -4. So -404. Okay, and then to get the second row, okay, here the next value for, okay, first Newton divided difference, your a b c d, you just move down. Just move it down. Now here, okay, a b c d, because the numerical method, the row by row, the pattern is actually you move down only. Then you calculate again. A is 5, b is 33, c is 0, d is -1, -28, and so on. Okay, and I also, okay, provide you the template, but the template for mine is actually last, I think last, okay, one step there. Okay, I think last time I provide until this one. So okay, initially I provide, okay, not enough, then you just increase and you just copy it down. Okay, why we use a, okay, Excel? Because pattern you can copy down easily. Oh, I think time's up. So maybe you can, later I will share you the, okay, marking scheme and you can have a look there. So please check if any error, just telegram me, because maybe time's up, we will dismiss and see you Tuesday. Tuesday, please do the quiz first and we have the class back 8:30.